Welcome back to Incremental, the continuous improvement podcast. This is our concepts edition for the week. I am Devin Bedoni.
And I'm Uriel Eisen. And a quote for the episode, if you don't know where you're going, you'll wind up someplace else, from Yogi Berra.
Yeah, I like this. I think it's kind of often overlooked in small business, or at least, well, maybe not all small business, but in the job shop world especially, I think there's kind of a like, well, we're just going to take what comes and we'll grow and we'll wind up where we end up, working with who we end up.
Yeah.
And I think it's important at some point to take stock and be like, I think actually we need to focus on this. This is going to be our specialty. This is our target market. These are our target customers. Otherwise, you can end up in just kind of like the crappy space that no one wants to be in.
Right, for good reason.
Yeah.
Yeah. I think also, I think Toyota mentions having some big audacious goals every year, and then like every 10 years. And I think that helps. I think like something I've been thinking a lot about is just getting accustomed to what is and sort of, and you stop being able to see and sort of accepting the state of things. Like our assembly station, it takes on average this much time to make each strap, and you can kind of go like, okay, that's just what it is, so great. Or you can say, all right, let's cut that in half, or something. And just having those, like thinking through where to put effort and where and where that can get you, I think helps continue to look at things critically and analytically. This
actually feeds kind of right into a point. I don't know if it's a thought that I was having. So I've been reading this Job Shop Lean book.
Yeah.
He has this like heavy focus on layout. Well, I'm reading the shop layout section.
Okay.
So obviously there's a heavy focus on shop layout in that section, but he's kind of being like, you can focus on the 8 lean wastes, but like really there's 2 that are kind of the big offenders.
And those are
moving and waiting. In terms of throughput.
Gotcha.
Which, I mean, you can we can get more into the details, but it just made me think that like people in general, I think, are not really good at like seeing negative space. Like we really focus on specifics and like look at like refining a small part of a process that we're working on. And it seems like a lot of all of this like TOC and different lean principles is like backing up to this global view and seeing all the negative space, not seeing the specifics of all the little details in your operations. And so it just struck me as this kind of like, oh, you need to just like really like flip your brain to like, don't look at the things you do, look at the things you're not doing.
Yeah. So actually to that point, we had an event and had an open shop, give some shop tours. And I mean, exactly to that point. So I forget what book this is from, but basically if you ask people how much of their work is sort of creative and value add, they'll typically self-report around 85%, with 15% sort of being, I mean, they're not saying waste, but 15% being sort of disorganized or just like working through recurring things or things going wrong. And it tends to be, if you audit it, that it's flipped the other way. So you have 15% is value add, and then 85% is waste. And so if you think about your ability to improve the efficiency of your process, most people tend to focus on the 15% value add. It's like, oh, we spray paint or we cut at an auto saw, and we could refine this a little bit. We could increase the feed rates. We could do all this stuff. And if you can cut that number in half, you're still barely ahead as if you can cut the other 85% in half.
Yeah.
And often the other cool part is often that other 85% is virtually free to cut in half. I mean, like minimal investment in equipment, technology, right? It's like really basic stuff. I think this is one of the things that makes lean and continuous improvement sort of not sexy. Is like you're walking across your shop to the trash can, like move the trash can. Right. It's like, well, let's talk more about like CAD and CAM and fancy end mills that can rip through aluminum faster.
Yeah.
I don't know. So yeah, I think
there's, this is a little bit of a tangent, but like, I wonder how much of it is actually like sort of like physiological and neurological, like our inability to see, like, I used to do a lot of like outdoor skills and like tracking stuff, and we would talk a lot about like how your eyes work. And we basically, the way our eyes are built, we're like built to see small detail in small areas, and like our ability, like our physical ability to see lots of things in our periphery and in like the wider space in general is extremely minimal compared to most animals. Like we have a very intense concentration of receptors at the center of our retina, so that when we're doing like a hard focus, like pinpoint view of something, we see tons of detail. And then around the rest of our retina, we have very few receptors, relatively speaking, compared to like a prey animal who has to see movement all around. But it's interesting to think about how those sorts of things like shape our behavior. If it maybe not like we're made to do something, but if you're not getting stimulus in a certain way, it's like you will never build that part of your brain. And I think we have to like really build this part of our brain of like seeing negative space, of seeing large processes as a whole, because we're sort of like fundamentally built to like be whatever, building a small tool as an individual.
Yeah, and I think it's fun to do like local optimization problems, right? I have experience with this.
Clearly.
Let's make it more efficient, and there's way more gains to be had in global efficiency. Yeah. Another interesting thing, you're talking about weighting and movement. So one thing Shigeo Shingo talks about is the difference between improving transportation operations and transportation processes. And basically transportation operations would be like installing getting a forklift, getting a conveyor belt. Like we need to move this thing from there to here. Let's make that more efficient. And basically that there's a lot more to be gained for cheaper by eliminating the need to transport. Yeah. To begin with. The other thing he talks about is reducing lead times, which I guess could be thought of as throughput.
I think so.
Is the two main factors are batch delays and process delays, and that basically amounts to waiting. We did an episode last week on SMED, and I think one of the little pieces of feedback I heard from a listener was that we didn't exactly hammer home why SMED is so powerful. But I think basically what SMED enables, single minute exchange dies, really switching parts quickly is, and I think we had a quote to this effect a number of episodes ago, but you want to be manufacturing everything you make, whether that's information or product, in the quantity and ratio that it is leaving your factory. And everything else is waste. And so that means doing a lot of switching of what each process is making. And so that's basically where SMED comes in. And one way to kind of start to see a lot of this stuff that I've found useful is sort of trying to look at things through different lenses. Two that I really like are following parts through the shop and like actually just like looking at all the parts and thinking about like their experience moving through the shop. Right? It's like that thing is sitting there. How long has it been sitting there? Where is it headed next? Like why is it sitting there? And similar with with information, it's sort of like and looking for waiting. There's a joke that I think we've mentioned that Toyota treats its car parts better than hospitals treat their patients. And it's basically this, right? It's reducing waiting. And like in a hospital, when people are in a waiting room and then there's the front desk who's in charge of sort of their KPI from their manager is sort of like get people checked in. So they're like jamming the top of the system, getting people checked in. And if you go in, do some paperwork, and then you sit for another 30 minutes, that actually means that the 30, 40 seconds that they spent getting you that paperwork should have been allocated to clearing someone out of the system or moving them to the next step instead of packing the top of the queue. And that time would make the total throughput go up. Yeah. And I think this is sort of the part of single piece flow that people don't understand, is it enables that to be very clearly visible, because you're basically saying any place we have a queue, eliminate the possibility of having that queue to let things immediately flow to the next process. And then if there's a bottleneck, it really elevates the bottleneck. And visibility wise.
Yeah, this kind of flows into the listener feedback we had. I'm blanking on the person's name. Brian Willman. Thanks for all the feedback, by the way.
Yeah.
He kind of was like boiling down what we've been talking about into like creating parallel processes.
Okay.
I think you could double this to say like parallel / simultaneous, depending on what the application is. But so essentially thinking about, instead of sequencing like processing and then setup and then processing and setup, of parallelizing processing and setup, and so that because the processing part is the part that makes you money, the setup is effectively waste. So in any process, anytime you can move things outside of that sequence to run in parallel and then meet at the key moment, you will increase your throughput and efficiency. And another thought I had about it, or another way of thinking about it, is like simultaneous processing, which would essentially be single piece flow, where in prior you'd have one person doing operation 1, and then they would move to doing operation 2, and then they could go back to doing operation 1. But while they're doing operation 2, operation 1 is static. Moving to simultaneous. And I think about this in the cooking example. If you have one person cooking and they are chopping and they're also stirring and doing whatever needs to be done at the stove, and they're also following the recipe, it tends to be a pretty slow process. If you have like some person calling out the recipe, just for an example, reading the recipe, calling out amounts, you have one person chopping and preparing stuff, and then you have another person working at the stove, which is more kind of how like a line cook in a kitchen would work. Things can move extremely fast through the production point.
Right. I think that sort of, to me, raises the question of what is your bottleneck, because if your bottleneck is sort of human time, then adding people to the stations, like I sort of got that feedback worrying about single piece flow when I don't actually have enough people to man every step of the process. The thing is, there still can be flow from the point of view of the product. I think to your point of parallelizing, that still gives you the ability to slow down the processes if they can run in parallel instead of like the thing is waiting. And that's really powerful. One thing I heard, which I'm forgetting where I heard it, but that Toyota often tries to, the first, like one easy step is automating the stopping process, the stopping of a process, because there is and the unloading of a process, because there's typically not a need for order, whereas there is typically a need for order at the beginning of a process. But we're seeing that in our sewing machine. Like even if you don't add people to our assembly area, being able to start the machine and walk away enables you to slow down that machine, which increases life, increases reliability. Or if you're buying a machine, you can really reduce the spec. And so there's a lot of power in that, regardless of whether you're manning every station, but just like thinking about.
I think looking at the simultaneous, like coming back to the manpower versus not, whether a process is automated, I think really defines whether you're going to do like parallel process or simultaneous sequence stuff. So like if you have an automated process like a CNC or a dishwasher, doing simultaneous setup operations makes a lot of sense because you don't need a second person for the automated process. And then if you're talking about
I see what you're saying.
Sequential simultaneous processes, the more of those you can automate, the fewer people you need, obviously.
Right.
But also it can be applied to a situation where a human is still doing each process, but it doesn't actually become simultaneous until there's a person at each station, which I think is what you were bringing up there.
Yeah, I mean, just like some of us don't just have people standing around waiting for something to do.
Yeah.
So it's still applicable. I'm curious, in that you mentioned in that book, they basically talk about 2 wastes. Do you think, I mean, Toyota spent a bunch of years and has boiled down to 8.
Mm-hmm.
Do you think that has to do with time horizon? Like, are they just saying to change your throughput tomorrow, these are the things you should worry about? Or do you think, because it strikes me that like freeing up, wasted human potential as an example, I suspect that if you focus on that, you also increase throughput because those people now have more time to work on improvements, for example, or...
Here, let me just open the book up. I think, he's basically was doing some analysis on actual product flow in shops.
Okay.
And, just for like one example here, there was a part where processing time was 315 seconds. Total flow time, like time within the facility, was 48 days.
Yeah.
And there's just sort of example after example where the work and process time is just like such an order of magnitude beyond all of the other stuff. And it's just kind of like you can put a dollar cost on delays.
Yeah.
And when you look at the typical sort of like value add to delay ratio, it's just kind of insane.
Yeah.
So it's sort of like this needs to be focus number 1, I think.
Interesting.
Or maybe it's just because it's in this chapter that's about shop layout. And so it's getting, a high focus. But the other part was that, so this is like another example for a forging. 82% of the time the forging spent in the shop was due to avoidable delays caused by the 7 types of waste shown in figure 4.8. And 5 of those, inventory, waiting, conveyance/transportation, overproduction, and operator motion, can be directly attributed to a functional layout. So
I see.
Yeah, he's using a functional layout is not good. It's the classic, his opinion, it's not good.
It's a flow layout.
It's not as good as a flow layout.
Yeah.
A functional layout is like you have a turning department, you have a milling department, you have a grinding department. So that was kind of his drive there, was like, that's a huge avoidable delay or a lot of avoidable waste. And then jumping through to the next part. And then he was basically like, and 90% of the time of that time was due to moving and waiting.
Gotcha.
So it's
sort of like focus on those chunks because they're big.
They're huge, and I think they're relatively simple to tackle.
Yeah. I mean, I've definitely seen that. I toured a factory a while ago where they had it by department.
Yeah.
And it's like, it's understandable why you'd set things up that way. Right? Like, I feel like
it follows a logic. It's not like totally
you're like,
random. Yeah.
Oh, we have all the support tools for all that stuff. And it feels very versatile, and it is very versatile because every single product that flows through there is similarly inefficient. That's right. It's all the same. You don't ever have to rearrange stuff for a new product. And then it was interesting. And then I think you end up, the issue is, and this is like Shingo talks a lot about this, the issue is that people tend to then focus on improving transportation operations. So it's like, oh, we have that department and we have this department. Wow, there's always materials going from our sawing department to our machining department. Why don't we put in a conveyor belt?
Right.
Why don't we buy automated little robots to move things between departments?
Right.
All that stuff. And instead of just like rearranging a bit.
And his thrust is that like it's sort of, and I think we spoke about this once, it's sort of unavoidable that at certain distances batch sizes grow. Or maybe I think if you worked really hard at it, like you're talking about, like putting in a conveyor, like you could keep the batch sizes small.
Yeah.
But it tends to be in a high mix, low volume environment, the batches just tend to grow. And those batches have costs. And then one point that he keeps bringing up as well is that if your turning department is across the factory from your milling department and you have a part that has both turning and milling, and the communication between those departments becomes really challenging. Yeah. So his other argument is basically that like it's going to reduce defects to have a cellular layout because the person doing the turning might be the person milling and can see issue, like comes back to basic, flow of like finding defects before they become big processes. But even if they are different people, they're like back to back or 5 feet away where they can just be like, hey, I'm seeing this thing.
You just passed me this. It has a defect.
Yeah. So I thought it was, it's really easy to just focus on like the part as like minimizing its delays. But I think there's a lot of other downstream benefits as well of communication and defect issues.
That's a good point.
Yeah.
Yeah. I wanted to go back. I don't know if it was 3 episodes or so. We talked about whether doing small improvements is sort of makes sense. Yeah. And I think something we didn't touch on is that basically like all those small improvements pay off in the long run. And so I think the issue sometimes for small business is that you need to make sure that you're matching your time horizon for that ROI to something that makes sense for the business. Like if you have a 10-year time horizon, but you have a 3 weeks of cash in the bank, like that's probably not a good way of moving forward. You're probably going to want to focus on things that have a quicker ROI. Yeah. Whether that's if you could think about it as like effort into like dollars out or to freeing up time. And so I think that's sort of the thing, like basically doing small improvements and analyzing your process is essentially never a waste of time if you look out 100 years.
Sure.
Because you're training a person to see waste, like that's a huge part of it. You're going to reduce the effort needed, and so you're freeing up their mind to do more useful things, like further analyze the task. Like there's just like really typically no downside as long as people aren't spending a huge amount of money, unless you run out of money. And so I think that's just like,
or if that money like really needs to go to something else.
Yeah,
like
right.
You could not run out of money, but you could never.
But it could limit you.
It could really limit you if you spend all your money and resources on improvements and don't like produce a new product or like reach out to new customers.
I feel personally attacked. Yeah, no, for sure.
Yeah.
I mean, I think going back to the quote from this episode, it's sort of like understanding the big picture is also important. Yeah. And understanding where you want time to be focused in a small business becomes probably more relevant because like if you have a team of 500, where each person puts their time is less of a percentage of your total business. I think it's still critical to understand where you're going. Yeah. But on a 5-person team,
where each individual puts totally.
Yeah. Anyway.
Yeah.
And I think as a small business owner, it is easy to be a little overwhelmed by all the big picture questions. Mm-hmm. And so like polishing your printer feels really good. And I don't know, like I just did that, it was really dusty and we cleaned it off, and I'm not sure what that ROI is exactly. It does start to enhance the clarity in the shop, I would say, is the big one. Of like being able to see when things are
Yeah.
out of order. I mean, we sort of talked a lot about that, but
Yeah. Interesting. One other neat little tidbit from this book was he distinguishes kind of the 3 types of production lines that you can have in a flow system.
okay.
One is a single process line, like what we would think of as a classic assembly line for a single vehicle, for example, like where you're just like making whatever Toyota Tundras all day long.
Yep.
The next would be a common process line where you can do maybe like 3 different things that have similar processes.
Or like your shipping department is that, right? It can process any materials going out.
I think that would be maybe, yeah. I'd have to think through the
common process line.
And then the last would be a similar process line. Basically like
so maybe that's a similar
varying levels of standardization, I think would be kind of how you'd break it down.
Okay.
And the way he's laying it out, or he said, based on this definition, like Toyota does primarily common process lines, not single process lines, because they do multi-vehicle assembly. But that most of us probably are more in like the similar process line. Well, I mean, you are kind of more in like the similar, single or common.
Yeah.
But the more that you can do to like the goal is always to be more like in the common.
Yep.
I think if you have a wide enough flow that you can like build cells for each common process. Each common process line.
Yeah.
But I think many of us are in a scenario where we don't have the overall flow, like the overall volume to dedicate single cells to common process lines. So we'll have a similar process line where we can handle 90% of our work through this single like sequence of machines or processes or whatever.
Interesting.
Yeah. And it's just an interesting way to like, I think we often think in terms of like assembly line or the alternative, which is like high mix, whatever. And, and not thinking about kind of like breaking it into multiple options.
Gotcha. Yeah, that makes sense.
Yeah.
Trying to think of examples in the shop. Like there's a shipping station where you're sort of trying to say, okay, we have easy access to a lot of different package sizes, right? Like envelope sizes. Like is a tape dispenser a common process line? Or, I mean, I don't know.
Yeah.
I don't know.
Probably. Yeah.
So speaking of overanalyzing simple things, we did so we wanted to build a table.
A physical table.
Yeah.
Where you put things on.
Yeah. Sit at, do work at. And so before doing that, you know, we've been starting to do A3 problem solving process. And so we decided to fill out an A3 for this table. And it was very interesting. I mean, kind of confusing, and I'm not sure we did it properly, but it did lead us to think more deeply about. So the question immediately is like, what is the problem we're solving?
Yeah.
And I mean, is it like free space? Is it about that? I mean, sort of what it came down to for us is that we wanted another workstation with a computer so that if like I'm answering emails and then Sam needs to set up the CNC right now, that's one spot. Yeah. Right. And so, but then that sort of feels more like a scheduling problem than the need necessarily. And so now you're saying, okay, it is a scheduling problem, but is it worth the effort of scheduling those two tasks? And maybe the answer is yes, maybe the answer is no. There's also sort of a flexibility question. But I thought it was kind of interesting because I think we often do these things sort of mindlessly of like, oh, this has nowhere to go. Let's get a shelf. It's sort of like, well, why do we have this? Why is a shelf, like, what is a shelf doing? Anyway, it was pretty interesting. And then trying to quantify what we're trying to achieve. It's like, what are the numbers to measure the current state of wanting another table? Is it about interruptions through the day? Is it about flex space? Is it about like, what are we doing with it? It was pretty interesting because I think like we just never spend time typically doing that. And I guess you could say it's a waste of time, but I don't think it is in the long run. I think you end up putting more time into solving root causes of issues instead of sort of, I mean, like the classic one is sort of like building a warehouse because you have tons of crates everywhere and your business is booming. It's like, man, this is great. It's sort of like, well, why do we need a warehouse?
Yeah.
It's like, well, we have all this stuff. It's like, well, why do we have all this stuff? And it took, when was the Industrial Revolution? I mean, it took
late 1800s.
Yeah, so it took like 180 years for anyone to really ask that question, right? Toyota in like the 50s or something, post-World War II. That's when they came up with this kind of approach.
Well, that would be less than 180 years, but
that's
was it the late 1800s or late 1700s?
I don't know.
When was what?
That's a good question. Anyway, I mean, it took, let's say, more than 10 years.
Definitely more than 10. Oh, no, 1700s.
Okay, that makes sense.
Yeah.
Yeah, because I was going to say, like, interchangeable parts and, like, Precision Valley. I feel like that was...
Yeah.
Just after the founding of the U.S.
Yep. Well, yeah.
So anyway, I think like that's sort of why it's not a waste of time. And it can be, I don't know, it's like, why do we need a chair? And then it's kind of like, well, how much do we need a chair? Not how much in terms of like 1 to 10, but like, do we need a chair for an hour or do we need a chair to sit here all the time? Can we borrow a chair? Can we eliminate the need for, like, I don't know, just everything you do, I think, for whatever reason, I don't know why it is, but it seems like we skip the step of really questioning what the thing achieves.
The fundamental goal.
Yeah. And I mean, I guess you could do the same for a car. It's like, what's the goal of a car? And I suspect it would also strip away a lot of the feature upsell stuff, right? It's like, okay, we're trying to get from point A to point B. Maybe AC is nice. Maybe like all these features are nice. Yeah. And then quantifying how much you're going to do different tasks with that piece of equipment. Yeah. Sort of really starts to drive what it should look like instead of just sort of mimicking what you've seen prior, I guess.
Yeah, totally. As you're saying this, I'm realizing like, as I mentioned, we're looking at moving to a new space potentially. Yeah. I feel like I have a good grasp on exactly why we specifically need to move and like how it will further the business. Yeah. But I haven't done like this whole process, and I'm kind of like, maybe we need to do this today.
It's super interesting. Yeah. We've done one for I think I mentioned for our assembly table, and the metric we chose, and you can have more than one, but the metric we chose was sort of like number of square inches that are free. Yeah. Because it just felt like it was really hard to do work at our assembly station. Yeah. And then the second we quantified it, it like really shifted our thinking and looking at our assembly station, and immediately gave us the tools to improve the area with like minimal effort. Basically, there was a computer that didn't need to be on the table because you never interact with it, and it was on the table. Yeah. And somehow we sort of became habituated to that state before, and then it was only through the process of sort of thinking through like, what are we solving? Because it's so easy to start redesigning the whole assembly station. Yeah. Right? It's like, all right, let's move it upstairs. We need more shelving space. And even that, it's like, well, why do we need more shelving space? Oh, it's inventory. Yeah. Can we cut inventories? Yeah. Can we improve the throughput through the paint area so that we have shorter replenishment times at the assembly area? I don't know. There's a lot of yeah. It's fun to think about, and we've really been enjoying filling out the A3.
How long do you take to do it time wise? Like, is it
probably not enough time? No, I mean process? The table one we probably spent like 25 minutes on it or something. And honestly, at this point for me, it's more a curiosity thing. Yeah. Like, what is this process? Like, yeah, I don't know. I don't feel like I have my head really wrapped around it. Yeah. and how to apply it and all that. So I just feel like we all need to practice.
Well, yeah, and just briefly going back to a point you made, like it can feel like a waste of time. I think the thing is we do it anyway. Like we spend the time thinking about these things. We just don't do it in a structured manner often. So I think it's not like you're going to save time, I don't think, by not doing this. You're just going to like put it in weird moments, and it's going to be sort of like half thoughts. And eventually you might end up somewhere functional or useful, but you might miss a lot. So I think it can feel like a waste of time because like 5 of you are going to be, or whatever, 1 or 2 of you, right, depending on the situation, are going to be like, okay, we're taking 20 minutes. We're going to all do this, like purposeful, dedicated, process. But I think it's a fallacy to think that you won't spend that time trying to figure out a solution otherwise, if there's a problem. Yeah,
I think numerically you're probably going to actually spend twice the time with a worse result, because what happens is, so Toyota tends to, and I don't know if this is still the case, but it's probably close. I'm trying to think when that book was written. Anyway, Toyota tends to spend about twice the time as other automakers on like solving problems, like designing a new car. Yeah. Right. It's twice the engineering time. They do it in half the engineering time at half the cost. Like half the man hours, half the cost, half the time, with a better product. Oh, and so basically
half.
Yeah, whichever way you look at it. Yeah, they're approximately so. And what they're reducing is rework, and the way they're reducing rework is by spending a proper amount of time on root cause analysis. And the A3 method is one that they've refined. Like there's no magic to it. It's just every time they had a failure and they were really alert to failures of, oh, we're redesigning this part. Why are we having to redesign this part? Right. And okay, what steps could we change to our process to prevent rework in the future? And so I think you will spend that time anyway. And in fact, you're going to spend twice that time. Right. But the interesting part to me is I don't think people are taught, I speaking for myself, I don't feel like I have done a good job spending time on the early phases of problem solving. I think I immediately jump to brainstorming, and I often don't spend enough time in brainstorming, and then I jump to final solutions and implementation. And I think I don't tend to spend like 60. I mean, if you look at it by space and time, it's like 60% of the time is on quantifying the current state and understanding the root causes and all that.
Looking at the A3 report.
Yeah, and how it's filled out.
Yeah.
So.
Interesting.
Yeah, it's basically front loading a whole bunch of extra work that no one wants to do. It's like, why aren't we moving? Like, let's do something.
Right.
And I'm definitely guilty of that. But it's been really fun.
Cool. Yeah, you should send me those.
Yeah.
The template.
Yeah. I mean, anyone can just Google one and pull out the one they like.
Is that what you did? And you just printed it on 2 sheets?
Yeah, I haven't found one that is rasterized. Maybe we should do one and put it up on our...
Oh, yeah.
Right, because I don't have a printer that will do A3.
Yeah.
I have one that does A2.
When I was at your shop the other day, I saw one on the side of the machine.
Yeah, that's on A2 paper, and it just doesn't leave you much room to fill anything out.
Oh, so it's not spread across 2 pages.
Right now we have one that's just printed out on A2 paper, and I figure it's better than nothing.
Yeah.
And we'll so next we need to, so we're doing an A2 process actually. Anyway, that gets us to time. I don't know if you have any.
No, that was it for today.
Yeah. So thanks all for listening. Hopefully some of that was interesting, useful, applicable to your current business. And we will be releasing another episode on Friday.
Catch you later.